So in chapter 3, we're going to start studying lines. And I started this video and my words kind of came out like garbage, so I deleted, but I didn't delete this sheet. This paper that's on the screen right now is almost everything we need to know about lines, and it's way too much. But anyways, we're going to be given equations, problems with equal signs, and they're going to graph into lines, and we're going to find different features of lines as we go through the chapter. I just want to talk about maybe two of the top two items on this summary of lines, because it's a little too early to summarize because we don't know what we're summarizing yet. But lines can be represented with many different equations, but mostly what the equations have in common is there's an x to the first power, there's a y to the first power, the x's and y's don't have exponents, the x's and y's aren't under square root symbols, the x's and y's aren't in the denominator of fractions. If we have a problem with an equal sign and there's an x to the first power and a y to the first power kind of anywhere on either side of the equal sign, then more than likely, if we're going to sketch a two-dimensional graph of that equation, it's probably going to graph to a line, something that looks like that or something that looks like that. And this equation that I started writing down, this, if I could actually spell, this is called the general form for a representation of an equation of a line. It has a number times x plus, possibly minus, a number times y equals to a number. That's what these symbols mean. If I have an equation that looks like this, a number times x plus, possibly minus, a number times y equals a constant, then that is considered in a general form for an equation for a line. That comes up a lot in this section. The next form is slope-intercept form. If I have an equation that has the same y to the first and x to the first, but it's solved for y, this is called a slope-intercept form or a slope-intercept equation for a line. The y is isolated to the left of the equal sign, and to the right of the equal sign we have a number times x and then plus or minus some constant. That's maybe as much as I want to say without just jumping into the problem. In this section 3.1, we're going to graph equations that I know ahead of time are going to have a graph that makes a straight line. We're going to graph equations by finding 3 points, and then we're going to connect the points with a line. Great time to have a ruler, and I don't know where I threw my ruler. I kind of like to have it. So let me take a minute here and see if I can reproduce the ruler that I used to have. I can't. I'll deal with it. So anyways, let me just jump into the section. There's not a lot of theory that's necessary, but there is cleverness that's necessary if you don't want to deal with an overload of fractions. So the first two problems that are on the screen right now ask me to find 3 points, plot the points, and sketch a graph. Both of these equations are written in the general form because they have a number times x, the number is 1, plus a number times y, the coefficient is 1, equals to a constant. This is the general form of an equation for a line. And if I'm asked to find points and I'm not given any sort of guidance onto how to get the points, then that's where I need to be creative, and that comes with experience. We don't necessarily have that experience yet, but we'll get it. This is the least dangerous kind of problem in terms of when I go to find points, I don't have to worry about getting points that are going to be awkward because they're fractions. So for part A of number 2, I need to find 3 points on the graph, and the way I find points is I pull a number out of the hat and I plug it in for either x or I plug it in for y. When I'm getting started and I can't really predict what's going to happen, if an equation is written in general form, I like to, unless it's going to introduce a fraction, for my first point, I'm going to let x equal to 0 and solve for y. For my second point, I'm going to let y equal to 0 and solve for x. And then for my third point, this is where I have lots of flexibility. As we get deeper into the section, I'll maybe talk about why I'll pick a different value for the third point if an equation is written in general form. But for lack of a better choice, I'm going to make x equal to 1. A lot of you that have a little familiarity with graphing, you might have made little t-tables, made a left column x and a right column y, and that's what I'm about to fill in. I'm going to create my points. I'm going to put them in the table. I'm going to write them as points. I'm going to plot them. So for my first point, I'm picking out of the air x equal to 0. It's usually an important feature on the graph to know the point that has a x equal to 0. So algebraically, I'm just going to take the x in the equation. I'm going to change it to 0. And I'm going to do the algebra. Well, there's almost no algebra there. 0 plus y is just y. This gives me y equals to 5. And I'm going to write that next to, in my table, I'm going to write it next to the y. And I'm going to put it down here. It doesn't matter if you show your points in a table for the 3 points or if you just kind of list them like I'm going to list them here. So I'm going to plot the point 0, 5. I'm going to find 0 on the x-axis because the first coordinate is 0. 0 on the x-axis is right at the origin. And then I'm going to march up the y-axis and go 5. I'm going to make a dot, and I'm going to write the coordinates of the point. So the point 0, 5, I've successfully plotted. For my second point, I'm going to let y equal to 0. I can take any value, any number, and plug that number in for x or plug that number in for y. It's just a matter of preference. And at some point, it's a matter of trying to avoid fractions realistically. When I plug 0 in for the y, I get x plus 0 equals to 5, or x equal to 5. So my point has 5 for x, and I got that point by plugging in 0 for y. So the algebra in this case gave me the x coordinate of the point. My guess at the beginning gave me the y coordinate. So the second point I'm going to plot is the point 5, 0. I'm going to go 5 in the x direction. That's the 5 from the 5, 0. And I don't go up or down, I just stay, I hover right on the axis. And then because I didn't have a better thought, I just let x equal to 1. And for my third point, I'm going to plug in 1 for x and solve for y. And I get y equal to 4. That's going to represent x equal 1, y equal to 4. I guessed on x equal to 1. My algebra gave me y equal to 4. If I was giving this lecture tomorrow, I might pick different points because it doesn't matter. Any three numbers, all 3 for x, all 3 for y, 2 for x, 1 for y, do the algebra to get the opposite value and create a point. All those points are going to line up on the same line. So now I've created all my points, and now I just need to sketch my graph. So I've found my 3 points. There's my 3 points written in a table. There's my 3 points written as points. I plotted the points. Now I'm going to sketch a graph. I wish I had a ruler, but I don't. Eventually, maybe I'll search one out. I can't draw on this. This is worse than anything. So there's a graph of a line, and usually I stop drawing, but the graph keeps going. I often, after I stop, put a little arrow pointing in both directions, signifying that the graph goes on forever. And I just, I just stopped where I stopped. Alrighty, let's move on to number 4. There are way too many problems in this section. Eventually I'm going to start skipping, but for now let me be consistent with myself, at least for what I'm being consistent today. For 4a, I'm going to get 3 points. I'm going to let x equal to 0 for my first point. I'm going to let y equal to 0 for my second point. And then I'm going to let, and I'm not going to let x equal to 1, but I'm going to pretend I'm going to let x equal to 1. And I'm going to show you where being clever is going to make your life easier. If you don't want to be clever, then you're going to have to fight with fractions, which is not the end of the world. So this right here, I can do math in my head and I can see the issue here. And I'll show you in a second what the issue is and how to avoid it. But to get started, I'm going to find 3 points. First point's going to have x equal to 0. And algebraically, I'm just going to go to my equation, x plus 5y equal to 10. I'm going to plug in 0 for x. That's going to make the left-hand side just be 5y equal to 10. And eventually, I do math in my head because the math sometimes is doable in your head. I wouldn't show this much work unless you need to show this much work. My first point, I plugged in 0 for x and the algebra gave me 2 for y. My first point's going to be 0, 2, and that's a point that's right on the y-axis. It's called a y-intercept when you find a point on a y-axis. When I let y equal to 0, algebraically I'll go x plus 5 times 0 equals 10. The 5 times 0 is 0. This is why it's nice plugging in 0. Usually it makes for nice algebra. Algebraically here, when I plugged in 0 for y, the y coordinate of my point is 0 then, I got 10 for x and the x coordinate of my point is 10. You're probably not going to have a predetermined graph, so you're going to have to make something yourself. And the only reason I created these is so that my graphs can look nice, nicer than they would be if I tried to freehand them. If I go for my third point and let x equal to 1, let me show you what happens. If I go 1 plus 5y equals to 10, minus 1, minus 1, this gives me 5y equals to 9, and then algebraically divide by 5, divide by 5. I get y equals to 9/5. I don't like having to graph fractions, so I like to do the math in my head ahead of time to avoid the fractions. 9/5 as a decimal is 1.8. And if I wanted to graph that, it's completely fine. I can graph the point 1 comma 1.8. This is the hard part to explain. What can I do to avoid getting 1 comma 1.8? So 1 and then up kind of 1.8 would be there. That's a completely acceptable point. It fits the bill of having 3 points. It's always clever. You're gonna never get a fraction. If there's a letter that doesn't have a coefficient, plug the number in for the other letter, you won't get a fraction. If I would have just flip-flopped this and said let y equal to 1, because the x doesn't have a coefficient, I don't have to divide to find the x, I wouldn't get a fraction. So I could have said this. I could have just been clever, that x plus 5 times 1 equals 10. That would give me x plus 5 equals 10 minus 5 minus 5. That's going to give me x equal to 5. That would represent the point x equal to 5, y equal to 1. Now I've given you 4 points. 1 that wasn't a fraction, and 5 ones about there. So now all these points should line up directly on a line. And this is the nice time to have a ruler, because it's hard to draw a perfectly straight line that actually goes through the points. But that's what we're shooting for. We're not shooting for something that has a wiggle in it. We're shooting for something that's more straight, but that's the best I can do without a straight edge. And sometimes I'll draw and my line won't actually go through the points. And then I fudge and just make the points bigger to make it look like it goes through the points. So that's not perfect, but it's adequate. keep plotting through these. Let's do 5 together just to knock out one of your homework problems. So for 5, I'm going to do what I like to do. I don't know why I had this pencil in my hand, but I do. I'm going to let x be 0. I'm going to let y be 0. And then all of a sudden, ugh. If I start doing math in my head, I can avoid getting a fraction. The idea here is if I plug a number in for x, how do I even explain this? I just do it in my head. If I plug a number in for x, I'm going to multiply and subtract. I'm trying to make it so the right-hand side is even because I'd have to divide by 2. So if I make the number I plug in for x come out to be an even number, if after I plug in a number for x, this is even, when I subtract it, the right side's going to be even. When I divide by 2, I'm not going to get a fraction. That's what I'm thinking, but that's too complicated. If you just want to plug in 1 for x and plot the fractions, that's fine. But let me do this. I'm going to plug in 2 for x. The reason I'm going to plug in 2 for x is because when I plug it, when I plug in 2 for x, I'm actually going to get the y-intercept. Oh, crap. Let me plug in 4 for x. I can do math in my head, which isn't good for anybody. This plugging in 2 for x was going to give me that middle point, and that I didn't want that. Plugging in 4 for x is going to make this be even. When I subtract it, it's going to stay even. When I divide by 2, I'm going to get a fraction. I'll show you why I scratched out that 2 when I find this. So we're doing 5. X-intercept, our plugging in 0 for x gives where the graph crosses the y-axis. Algebraically, I get 3x minus 2 times 0 equals to 6. The 2 times 0 is 0, so this just gives me 3x minus 0 equals 6, or 3x equals 2. And here's where the x equal 2 came up. I couldn't think straight, but I knew I couldn't plug... Here, this is garbage. So sorry. I start thinking about something and not what I'm teaching, and then all of a sudden I'm getting garbage written down. Here, I said let x equal to 0, but what did I go and do? And I put y equal to 0. So I'm reevaluating. I still want to plug y and x for 0. I like those choices because a lot of times I'm asked to find those values anyways. So when I plug y in for 0, which is what I did here, I did 3x minus 2 times 0, which gave me 3x minus 0, which gave me 3x equal to 6. I divide by 6 and I get x equal to 2. The reason I didn't put 2 in over here, because I knew that algebra that was going to give me that. So one of my 3 points is the point x equal to y equal to 0. Now let me try to physically plug in 0 for x. I'm going to go 3 times 0 minus 2y equals to 6. This gives me 3 times 0 is 0, minus 2y equal to 6. That leaves me with minus 2y equal to 6. Divide by negative 2, divide by negative 2. That will give me y equal to negative 3. So that point is x equal to 0, y equal to negative 3. I can write it as a point, or I can write it in a table. X equals 0, y equal negative 3. And now for the third point, if you plug 1 in for x, you'll just get a fraction. It's not that big of a deal. But I'm plugging 4 in for x to avoid the fraction. So I'm going 3 times 4 minus 2y equals to 6. As long as this came out to be an even number, I was going to be golden. That's the reason I chose 2, because 2 would make this even, and I knew I wasn't going to get a fraction. But 2 came up here, I wouldn't have gotten a different point. So now I'm going to minus 12 and minus 12. That's going to give me minus 2y equals to minus 6. And then divide by negative 2, divide by negative 2 gives me y equal to 3. So when I go to write my point, I plugged in 4 for x and I got 3 back for y. You could write your points like I have there. That's considered finding 3 points. Making a table like I have is considered finding 3 points. And now I'm going to plot them. First point is 2 on the x-axis. Second point is -3 on the y-axis. And last point, right 4, up 3. You can tell you've made a mistake if the points don't line up. Like if my third point was down here somewhere and I get like a triangle, then I know that I've made a mistake on one of my points. You really technically only need 2 points to graph a line, but getting that third point gives you some assurance that you haven't made a math error along the way. Alrighty. Too many problems. So the first 8 problems are all written in general form, and when a problem's written in general form, my go-to is let x equal 0, let y equal to 0, and then plug another number in and hope you don't get a fraction. If you get a fraction, just plot it. So for number 8, finding 3 points, I'm going to let x be 0. I'm going to let y be 0. This is considered finding points on the axes. Points on the axes are called intercepts. We'll get that a little bit in this section. And then, because the y doesn't have a number in front of it, I can plug any number in the world in for x, and I won't have to divide to solve for y. I don't have to worry about fractions if I plug a number in for x. I'm just going to do x equal to 1. So algebraically, the first one, I'm going to go 2 times 0 plus y equals 16. That gives me 0 plus y equals 16, which is y equal to 16. So my first point, I plugged in 0 for x and got 16 for y. That point's considered an intercept because it's going to be on an axis, and because it's on the y-axis, it's a y-intercept. So I'm going to plot my first point, x equals 0, y equal to 16. Now I'm plugging 0 in for y, getting 2x plus 0 equals 16. The 0 goes away, I get 2x equals 16. Divide by 2, divide by 2. I get x equal to 8. That gives me the point 8, 0. And that's going to be on the x-axis. If you look at my solutions, I may not have exactly these points because it doesn't matter. Any 3 points in the world are going to be adequate, and even if I don't label the point 0, 16 and the point 8, 0, my graph's going to go through those points. So you may get 3 totally different points than I do on your solution when you write up one compared to my solutions if you check it. Doesn't matter at all. Any 3 points are adequate. I'm just making the easy points for the video with the points that don't require a lot of thought and are kind of easy. Whereas maybe sometimes by myself, because I do math, pretty comfortably in my head, well, maybe I pick some more obscure points for, reasons that I don't want to even try to explain because it's just the logic that my mind is thinking at the time, and maybe it doesn't really even make sense to anybody but me. But, you don't want to have to plot a bunch of fractions if you can help it. So for my third value, I plugged 1 in for x. I did the algebra without speaking. And that gives me the point 114. So 1 in 14. Great, great, great having graph paper. And I don't have graph paper. I just printed this out. The website I use, something like this. Padawan, I think .uk. It's a program that I use. It's freeware that I use to make all my graphs. Blank graphs, graphs that have features on them. That's what I do for all of them. We're at 25 minutes. This is going to be a 3-part video. It's a really long section. Eventually, I need to start skipping some problems because doing every problem is going to drive both of us crazy. Let's pause and do a part 2. We'll definitely have a part 3.